Assalamualaikum warahmatullahi wabarakatuh. Today I would like to continue the video. This video will be discussed. In this video, we will be discussing on the beam analysis, including support settlement effect. Beam analysis will be analysed using stiffness method, using stiffness matrix method. So we will look at how to calculate, how to consider the effect of support settlement in the analysis in order to analyse the unknown displacement, and after that to calculate the reaction at the support in beam. Okay, so since I have explained in detail example in my previous video, so now I would like to focus more on the procedure, how to consider the settlement, the difference without and with considering the settlement effect. Okay, the settlement effect. Of course, when the structure has to consider the settlement effect, when the settlement occur, so it will give different answer, it will give different value of displacement, it will give different value of reaction. Okay, so basically when we have beam, like this, so let's say we are going to analyze beam, continuous beam, let's say like this. There are three element beam, so UDL, moment. Okay, let's say only this. So support A is fixed, support B, C and D. So let's say the distance, okay, this is 5 meter, this is 4.5 meter. Okay, and another one is 4 meter. Okay, so the UDL is about UDL is 30 kilonewton per meter, and applied moment clockwise, this is 350 kilonewton meter. Okay, so step number 1, the most important part that students should consider before start doing analysis, we must divide the system into unconstrained and constrained system. Into unconstrained and constrained. Okay, unconstrained and constrained. So I believe everyone of the students are now capable to draw, to sketch the diagram and put the degree of freedom according to unconstrained and constrained. So for those who are new to this, or new to this, so I want to explain again that actually degree of freedom, what is the meaning of degree of freedom? Degree of freedom is actually displacement component. And at each nodes in beam there are 2 degree of freedom. At each node. And we only need to consider the degree of freedom in Y and Z direction, because in beam, understood, in beam there is no axial force, there is no horizontal force, there is no horizontal displacement. So we don't need to count the displacement and the force in X direction. So we just have to focus on the displacement and forces in Y and Z direction. Okay, so based on this example, based on this beam, by looking at the support at A is fixed, B, C, D is roller. So normally what I told student is start to identify the degree of freedom in constraint system, because it is actually equivalent to unknown reaction in the system. So basically by looking at the support, we know that there are 1, 2, 3 at A, B, C and D. So they are all 6, but we don't need to calculate X to consider X. So A we only count 2. Degree of freedom two unknown displacement. We only count 2 based on the degree of freedom based on the sign convention. So 2 at A, 1 at B, 1 at C, and another 1 at D. So total is 5. This 5 is considered as 5 degree of freedom in constraint system. So in total there are four nodes, and 2 each node, 2 DOF each node, so total must be 8. So, and 5 have been put at C. 5 have been put at C. Remember, we don't count X in X direction at A, so we only count A as 2 degree of freedom, because we will focus on the sign convention in Y and Z direction. This is the sign convention. Okay, so 5 have been put in degree of freedom. 5 degree of freedom has been put under constraint system. So remaining 3 must be put in unconstrained system. So 5 in constraint system is actually represent the unknown reaction forces, unknown reaction, and 3 degree of freedom represent unknown displacement. And using stiffness method, we will determine the displacement first, using displacement, then only we can calculate the reaction at the support, the reaction at constraint system. Okay, so and this is why since displacement will be determined first, that is why we need to label 1 to 3. We need to label one start from unconstrained system. So we will label the degree of freedom. Okay, I will sketch the diagram, the beam, I will sketch only. Okay, like this, sketch only. So label A, B, C, D, A, B, C, D. This is just to guide us how to label the degree of freedom. So looking back to the main diagram, so at B, BY, CY, and DY is the reaction, the vertical reaction at B, C, and D. So we will put here B, C, and D in Y direction. And at A there are Y as well as Z. So we need to fulfill remaining 3. Remember that each node must have 3 nodes. Each node must have 2 degree of freedom. Means that we must make sure that at A there are 2 YZ, at B YZ, at C YZ, at D YZ. So at A there's no need to put the degree of freedom in unconstrained system, because 2 has been put at A. So at B, since only 1 has been put in constrained system, so we have to complete the degree of freedom at unconstrained system. We have to put Z at B, Z at C, Z at D. So now in total we can calculate that there are 8 four vertical, in Y direction, the vertical direction, and another 4 in Z direction. So we need to label. So we start label at unconstrained. We must start label at unconstrained. So we put 1, 2, 3, 4, 5, 6, 7, 8. So this is just the guidance. So actually you can label in any direction, you can also start 1, 2, 3 at DCB, doesn't matter. This is just the method of position. Okay, so we have labeled this. There are 8, 1 until 8. So 1, 2, 3. 1, 2, 3 represent 1, 2, 3 represent unknown displacement. 1 to 3 represent unknown displacement. Okay, and 4, 5, 6, 7, 8 Q4, Q5, Q6, Q7, Q8 represent unknown reaction at the support. Okay, so Q and D, both Q and D, we must look at to this. Okay, to this, let's say if we want to look at this number, this degree of freedom in terms of displacement, D1, D2, D3 represent moment. By looking at the diagram, so since it is representing by Z, since 1 to 3, since it is representing by Z, so it is D1, D2 and D3 unknown displacement. And for numbering 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, so in terms of Q, Q4, Q5, Q6, Q7, Q8 representing unknown reaction. Okay, so AB is element number 1, BC is element number 2, CD is element number 3. Okay, so we step number 1. Step number 1, of course, the most important step that you need to do is number 1. You need to establish K1, K2, and K3. K1, K2, and K3. Remember that this is element global stiffness matrices. This is element global stiffness matrices. We calculate this based on the formula given in page 1 appendix. So you just need the for beam, you just need to include the length as well as EI in order to get the stiffness, the element stiffness matrix. Okay, for beam you don't need to put the arrow, you don't need to put the coordinate, because beam has same local and global coordinate system, and the direction is always going to the right side. So we don't have to calculate CX and CY as well. Okay, so beside K1, K2, K3, this is actually the compulsory step, because from this we will establish the structure stiffness matrix. Okay, for step number 2. So for beam, we need to establish as well the equivalent element nodal forces. For beam, equivalent element nodal forces Q naught. Equivalent element nodal forces Q naught. We have Q naught 1, Q naught 2, and Q naught 3. We use the symbol as Q naught. Q small letter is to represent the element. Q small letter is to represent the element. Q capital letter is to represent the structure. We have Q naught 1, Q naught 2, and Q naught 3. What is this? This is called as equivalent. This is equivalent element nodal forces. Equivalent element nodal forces. There is a word element. Okay, element means that it is Q naught small letter. Q naught small letter. Okay, so these two steps is very important. So just use the formula. For Q naught 1, Q naught 2, Q naught 3, we need to refer to the formula in appendix page 3. In appendix page 3, I have explained in the previous video how to get the value of Q naught 1, Q naught 2, and Q naught 3. However, what I want to highlight is the label for the K1, K2, K3, as well as Q naught 1, Q naught 2, and Q naught 3. The label is very, very important, because if you don't put the label, you cannot produce the structure stiffness matrix as well as equivalent nodal forces Q naught capital. Okay, so the label must be, we must label this, okay, based on the near and far end position. Near YZ, okay, near YZ for beam and far YZ for beam. So we will get the matrix 4 by 4 based on the 4 degree of freedom in the element. Okay, so we will have K1 4 by 4, Q naught 1 for value. Okay, K2 4 by 4 as well, because this is for element. Q naught 2, okay, like this. and K3. K3, it is 4 by 4 matrix, and Q not 3 is 4 value. Okay, based on 4 degree of freedom. Okay, so let's look at back to the diagram, this diagram. Okay, this diagram. So for element number 1, of course, element number 1 is AB. Element number 1 is AB, element number 2 is BC. So we just label back. We just label back this as element number 1, element number 2, and element number 3. So this is element number, this is element 1, element 1, element 2, element 3. 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 So K1, K2, K3. So for element number 1, AB, element number 1, AB, at A will become near N, B will become far N for that element, A and B. So A is near, B is far. So YZ, near YZ, far YZ is 4, 5, 6, 1. Near YZ is 4, 5. Near YZ is 4, 5. Far YZ is 6, 1. So it is 4, 5, 6, 1. So we have to label 4, 5, 6, 1 here. 4, 5, 6, 1. 4, 5, 6, 1 as well as 4, 5, 6, 1. Okay? 4, 5, 6, 1 for K1 and Q not 1. Okay, we continue to element number 2. Element number 2 is member BC. Element number 2 is member BC. So B will become near N. B will become near N. C will become far N. Near and far. Near YZ is 6, 1. Far YZ is 7, 2. 6, 1, 7, 2. 6, 1, 7, 2. So we need to put 6, 1, 7, 2. 6, 1, 7, 2. 6, 1, 7, 2. And 6, 1, 7, 2. Okay, 6, 1, 7, 2. So we consider element number 3. Element number 3 is member CD. Element number 3 is member CD. Member CD, C will be the near end. D will become the far end. So at C, the label is 7, 7, 2, 7, 2, and at far it is 8, 3, 7, 2, 8, 3. So the label for K1 as well as Q not 3, K3 as well as Q not 3 is 7283. So it is 7283, 7283, 7283, 7283. Okay, 7283. Okay, now after this, once you have all this value K1, K2, K3 as well as Q not 1, Q not 2, Q not 3. Actually, from this we can straight away write the stiffness equation. Okay, we need to write the stiffness equation. Stiffness equation. Stiffness equation in full. Of course, we have this. Q is equal to, okay, the formula is Q is equal to KD plus Q naught. Okay, Q naught is equivalent element nodal forces. We use capital because this is to represent the whole structure. Okay, means that Q will we have Q at position 1 until position 8, and then we will have K 1 until 8, K 1 until 8. This times with D1 until D8 plus Q naught 1 until 8. Okay, we have like this. We have like this. Okay, all from 1 to 8. From 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8. Same goes to this D. D we have 1, 2, 3, 4, 5, 6, 7, 8. And this one position 1, 2, 3, 4, 5, 6, 7, 8. Okay, so of course for the case where we don't need to consider this the settlement at support displacement is equal to 0. At support displacement is equal to 0. That is why we need to understand this very well. That's why we need to understand this very well. In constraint system, displacement is equal to 0. In constraint system, displacement is equal to 0, except the support settlement. Okay, except when the support settlement occur. Without support settlement, all D in constraint system is equal to 0. D in constraint system is equal to 0. D in unconstrained is the unknown. D is in unconstrained is the unknown. D in constraint is equal to 0. However, when we have effect of settlement, then we need to consider in constraint system at particular position. Okay, at the given value of settlement. Okay, so this is actually the stiffness equation for all for the structure. So however, remember that when we since all displacement is 0, here displacement start from 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. There are 5 value of 0 displacement. So actually when this we times with 0, when k times with 0, we get 0. So it is just like we cancel line number 4, 5, 6, 7, 8. Okay, because it is just mathematical formulation. Whenever the displacement is 0, whatever value at position 4, 5, 6, 7, 8 in the structure stiffness matrix doesn't give any value, because we cancel with the 0 displacement at 4, 5, 6, 7, 8. So to solve for the unknown displacement, that is why to solve for the unknown displacement, if the question doesn't ask you to give in full equation, you just have to consider the stiffness equation in unconstrained system. This is the reason why I always advise my students to start with sketch the diagram according to unconstrained and constrained system, because we will solve for the unknown displacement by only considering unconstrained system, because in full, when there is no settlement, the value when times with 0, we will get 0. So we actually need to consider this three value, as well as this three value. Okay, without considering settlement. So after this, we will get we will reduce it. We reduce the equation, like this. Okay, 1, 2, 3, D1, D2, D3, plus with Q naught at position 1, 2, 3. Okay, so this one is stiffness equation corresponding to unconstrained degree of freedom system. So if the question asks you to calculate the unknown displacement, to calculate unknown rotation, or to calculate non-zero degree of freedom, because 0 degree of freedom is actually D is equal to 0 degree of freedom, because degree of freedom itself, the meaning is displacement component. So 0 degree of freedom means D is equal to 0 located in constraint system. So vice versa, D1, D2, D3 is non-zero degree of freedom. So we solve this and we will get D1, D2, and D3. We will get D1, D2, and D3. D1, D2, D3. Okay, straight away we get the value. Okay, this is when we don't need to consider the effect of support settlement. So now I want to continue. Okay, how to consider the support settlement into the beam analysis? How to consider? Okay, so let's consider a settlement occur at support settlement. Support settlement occur in Y direction. Support settlement. Support settlement is for the vertical reaction. the rotation, if displacement, if we use the word displacement, it can represent the rotation as well as the vertical displacement. If we use the word support settlement, it means that it is settled downward, means it is in the vertical directions. And support settlement always occur in constraint, because support is in constraint system. Support is constrained. So support settlement means settlement must be put in constraint system. So by looking at this, by looking at the constraint system, there are four y value. 4, 6, 7, 8. 4, 6, 7, 8. Means that we can consider the settlement effect if the value of displacement is given at any position given in the question. For example, if the question if we need to consider the settlement is given in at A position, so we need to put the value at position number 4. If the settlement is given at D position, if the settlement is given at D position, then we need to consider D8 as the value of displacement. If the settlement is given at C, then we need to change D7 to the value given. If the settlement is given at B, so we need to put D6 not equal to 0 but equal to displacement. Okay, let's say I want to put the settlement, the effect at position B. Okay, so in the question, it is like this. Support AB, support B. When the settlement occur, of course in the question there is a statement mentioning about settlement at which support. Okay, at which support. So let's say the support B settle. Support B has settled or displaced. Okay, slip. Okay, normally if it is for the vertical displacement, it is settlement. If it is for the horizontal displacement, horizontal means that support displacement in horizontal direction, normally you will find the word horizontal slip horizontally, slip in right directions or left direction. However, for the settle, we will always assume that the settlement means downward. Support B has settled 30 mm downward. Support B has settled 30 mm downward. So what we need to do is, so be careful. I hope all the students focus on this. Support B settle. So what we need to do is, we need to find the level, the degree of freedom number at position B in Y direction. Okay, again, the students need to find what is the label. The student needs to find what is the label in Y direction at B. So look at back to the diagram. Okay, at position B, Y direction is the symbol is 6. The degree of freedom representing Y direction at position B, the symbol is 6. Okay, the symbol is 6, means that D6 is now equal to the displacement given. D6 will be equal to the displacement given. So D6 is equal to, settle downward, sign convention upward, so it is negative 0.03 meter. 0.03 meter. D6, because 6 is the level of displacement in Y direction, because it is settlement. Settlement means in the vertical direction, settle. Okay, so D6, because the label is 6, D6 is negative 0.03. However, it will depend on how you label on the numbering. If you label position B as 7, so it is D7. If you label position B as 8, so it will be D8. If you label position B as 5, it will be D5. It will be depend on the label. Okay, on the label at the first stage of the analysis. So how to consider this? Actually, to consider the support settlement, it is just the mathematical solution. How you will analyze the matrix multiplication whenever D6 has value. Means that we will, okay, so in this equation, so D6 will have the value. D6 is not going to be 0 anymore. We have to put the value of D6 given. And actually in the stiffness matrix, we need to have the value here at position 6. Means that we need to have this value, and this value. Three value means 1, 6, 2, 6 and 3, 6. 1, 6, 2, 6 and 3, 6. 1, 6, 2, 6 and 3, 6. We must have all this value. So even though we maybe don't write in full, but don't worry, 1, 6, 2, 6 and 3, 6 we can find in the K1, K2 and K3. Okay, so I will rewrite it back, the equation, after considering the support settlement. After considering the support settlement, we will get the equation, the stiffness equation, like this. We have Q here. Q equal to K from 1, 1 until 3, 3. And this will be times with D1, D2 and D3. D1, D2 and D3. So this plus with position 6 just now, position 6 times with a negative 0.03. Okay, this is D6. Okay, times with D6 plus the Q naught. This is Q naught lah, Q naught. So this is Q naught. We have 1, 2, 3. Q naught we have 1, 2, 3. So it is just the same with what we have calculated previously without considering settlement. So the difference between analysis of displacement with and without considering settlement is only at this part. Alright. So why we need to differentiate like this? Because in the first phase here, alright, D1, D2 and D3 is unknown. D1, D2, D3 is unknown, and we need to calculate the D1, D2, D3 as the output in this analysis. So D1, D2, D3 we calculate with K from 1, 1 until 3, 3. From 1, 1 until 3, 3. So this is 1, 2, 3. 1 at position 1, 1 times D1, at position 1, 2 times D2, at position 1, 3 times D3. So at position 1, 6 times D6. 1, 6 times D6, because that is the principle in matrix. That is the principle in multiplying the matrix, multiplication, matrix multiplication. Okay, it is 1, position 1, again 1, 1 times D1, 1, 1 times D1, 1, 2 times D2, 1, 3 times D3, and 1, 6 times D6, because 1, 4 times D4, but D4 is equal to 0. 1, 4 times D4, but D4 is equal to 0. So we don't need to write in this equation. 1, 5 times D5. D5 is 0. So 1, 5 times D5. D5 is 0. So we don't have to put into this. Okay, 1, 6 times D6. 1, 6 times D6. 1, 6 times D6. 1, 7 times D7. 1, 7 times D7, because 1, 7 times D7. D7 is 0. So we don't need to write it here. And 1, 8 times D8. 8. And again, D8 is equal to 0. D8 is equal to 0. So 1/8 times 0, we get 0. So we don't need to write in this equation. So what we need to put inside this equation is when ever we need to consider settlement at that position. Okay, we have to check the label, what we label, what number we use, okay, to represent that one. And then we have to consider that position in the matrix K, matrix K, to consider the value. Okay, so same goes to line number 2. Line number 2 is to 1, to 2, and to 3. To 1, to 2, and to 3, and then to 6. To 1, to 2, to 3, to 6. To 1, to 2, to 3. To 4 also have value, but to 4 times with D4, 0. To 5 times D5, 0. And to 6 times D6. To 6 times D6. To 6 times D6. To 7 times 0. To 8 times 0. Okay, so that is the principle of matrix multiplication. So by having this, so you will get all this. You will get all this as values. Okay, values. This value is in this form 1, 2, 3. Okay, so we need to plus with this. Okay, so we get this as one value. So this is how actually we can consider the support settlement. When the value of settlement is given in the question. So lastly, we will bring this value to the other side. So finally, we will get the equation just like this. And D, okay, like this. Okay, so here the value here, okay, the value here is the value in the left side is basically come from nodal forces Q. Okay, nodal forces Q. It also come from equivalent nodal forces. Q naught, and it will also include with the value from support settlement. Okay, so I hope you understand the concept of support settlement, how we need to consider the support settlement. The full example I have recorded as well, the full example, and I will also uploaded by today, inshallah. Okay, so if you have question, if you want to request me to do another review, please tell me, and inshallah I will review. I will make another video to discuss together. Okay, so that's all. Assalamualaikum warahmatullahi wabarakatuh.